essentially we're talking about a paper we've been recently had published on ensemble learning. So just to give you a bit of a motivation of why we did this, we have a lot of data in Odyssey, and we have the patient level prediction framework that lets us develop models pretty efficiently. But what we find when we've been doing predictions is that when you develop a model in one data set, for example, one of the data sets we have at Janssen CCE, it doesn't necessarily work as well when you transport it into a new database like Medicare. So you can see here, CCE, it's a younger population, it's people who are commercially insured, so they're generally healthier. And then you've got Medicare, which is the over 65s, and they normally have a few more comorbidities. So the model may do pretty well in CCE when it's trained in CCE, but when you try and apply that CCE model to Medicare, the performance obviously drops quite a bit. And we see this pretty consistently. Medicare is pretty one of the databases that it's harder to actually get a good model on. Now, this is problematic because ideally, a lot of times when we're developing prediction models, we're trying to develop a generic model that you could use in a clinical setting. And if the model is being developed in a data set like CCE, which is just younger patients, there's a good chance that it may not do very well for the older patients. So if we developed a model in CCE, we may have issues if we wanted to transport that into a clinical setting. So this kind of motivated the idea of, can we try and combine prediction models that are developed on different patient populations? So you got CCE, which is the younger and healthier patients. You've got Medicare, which is the older patients. And then we have data sets across Odyssey that are in different countries. So we have all these different mix of patients within each of our data sets. So we have the source data that's very different, all gets mapped to CDM. We can then apply our PLP framework to get our models. And then the question is, can we somehow combine these models into one single model? And that's what ensemble learning is. So ensemble learning is you take a set of existing models and you combine them in some way to give you some overall model. And the idea is that this ensemble model should actually perform better because it's just being, for example, one database has the under 65s and one dataset has the over 65s, the ensemble is going to combine those together. So hopefully it will be more transportable, and that's what we're trying to look at. So we experimented in the Odyssey style that we do with 21 prediction problems with 5 different databases. And we looked at, within the same prediction task, can we combine the models developed on different data sets? So database 1 model is predicting the same task as database 2 model and database 3 model and database 4 model. And then we're going to look at different ways of combining that. For time, I'm not going to go into too much details, but if you want to know more about the different strategies on Ensemble, there's some references in the paper. But the 3 that we looked at were fusion, stacker, and mixture of experts. So just a quick summary. Fusion models effectively do some weighted combinations. So if one model is saying you've got a 20% risk and another saying you've got 30, another saying you've got a 25, and another saying you've got a 35, it would basically take the mean of those if you do a uniform fusion. But you can also assign a higher weight to some of the models if you know one model is better than the other. So that's what the fusion's doing. Mixture of experts, it would basically pick one of those base models that seems most suitable for you. So if you had CCE, which is under 65, and you had Medicare, which is above 65, and some other databases, if for me, for example, I'm under 65, it may say that we may have a rule that says pick the model that basically I'm more like in terms of age, and therefore it would be the CCE model. So it may just say, for me, it picks CCE, but if there's someone else who is older, it may take the Medicare model. So that's the mixture of experts. And then a stacker is a slightly more advanced version of a fusion, where you basically learn how to combine the models. So you can fit something like a logistic regression onto those predicted risks from the models 1 to 4, or however models you have. And we use the logistic regression for this. You can do more advanced models, but for this experiment, we just did logistic regression. The problem with the stacker, though, is you need more data. So you have to learn the weights effective if you're doing a logistic regression, and that requires you to have more data to learn from. For the experiment that I'm about to show, we actually assumed that maybe in the setting you're going to be applying the models, you would actually have a limited amount of labeled data. So we experimented with a stacker design where we used some data from the database you're going to basically applying the model to. So that's going to come up a little bit because you're going to see that had a little bit of an advantage because it's not completely unseen, the database. So the design we did, we looked at 5 different databases. 21 different prediction tasks, and then we looked at different fusions, different mixture of experts, and different stacker strategies. We evaluated for the discrimination and the calibration. So how well does the ensembles or the base level models rank? How accurate are the mean, are the predicted risks? So is the prediction actually true? So if it's saying you have a 10% risk, do you really have a 10% risk? We did leave one out database design. So we effectively had 5 databases. So for the ensembles, we used 4 databases and combined them somehow with some ensemble strategy. And then we tested it on the 5th database, which was kind of held out. So it was this nice design because we had 5 databases, because we have Odyssey and we have the standardized data, we're able to do this strategy, which is quite nice. And then the results. So I've got a plot here for the discrimination. And effectively what you're seeing here is on the y-axis, this is telling you the difference between a model if you fit it into a database minus a model like the ensemble when you applied it to the new database. So that unseen database, basically, we fit a model in that to give us our benchmark performance. And then we tested how well the ensemble would have done, or the level 1 models would have done if they got transported over. And if you see that the values around 0, it means that a model that transported over to the database did as well as fitting a model in that database, which is really good. So 0 is pretty good for transportability. Above 0 means your model did better. Your ensemble model or your level 1 model did better than fitting a model in that database. And then below 0 means that your model is kind of less transportable than if you actually were able to fit a model in that database. So you can see most things were below 0, which you would expect. And then what we've got here, I'm highlighting, is the models developed on one database, so the non-ensemble models. And you see the non-ensemble models, they generally fall below the 0, but not too far below the 0. So in general, actually, the models in terms of discrimination aren't too bad at transporting. But then if we look at the fusion ensembles, so this is when we combined the database models, they're actually all pretty much around 0. So they actually performed as well on new data as if you had fit a model in that new data. So these were extremely well kind of performing in terms of discrimination, which is pretty good. And then we had some other ensembles like the mixture of experts and the stackers. These actually didn't do as well. The stacker here, the middle one in this kind of this red box here, this was if you only had a small amount of data to learn those combinations, so to learn the logistic regression. And if you didn't have enough data, basically the model did very poorly because it just couldn't fit well. So you could only really do well for the stacker if you had a lot of data. But then in that situation, why not just fit a model in that database? So the fusion ensembles did extremely well for discrimination. The other ensembles didn't do quite so well. And then if we look at calibration, we have a similar thing where we're looking at basically now the difference between the observed risk and the mean predicted risk. So again, a value of 0 means that you're pretty accurate at your prediction. If it's saying you've got a 10% risk, you have a 10% risk. Anything above or below 0 means you're miscalibrated when you're applying the model to the new data. And what we see here is pretty much from all of the models, the individual database models or the ensemble models, the calibration was extremely poor. The only one where the calibration was good is this stacker. But this like column here is actually a stacker when you use all the data in the holdout data. So it's refitting, it's recalibrated. It's kind of got an unfair advantage. So I would kind of ignore that. That's not really a fair comparison here. But if we look at the others that are non-stackers, all the models are miscalibrated. And this really just highlights what we've seen all along. Calibration is this issue. Whenever you apply a model to a new database, you really have this issue with calibration. It's just not doing well. It can rank people correctly, but the actual risks that it's telling you are not good. So we've built an ensemble learning package that you can actually use to do ensemble learning. So if you're interested in doing this ensemble and you want to try and come up with models that are more transportable in terms of discrimination, we still need to fix that calibration issue. There is a package now that's part of Hades that has all the vignettes if you want to see how it's actually used. And this is being updated pretty a lot. So you're going to see a lot of new stuff being put in here for the next year or two. So if you have any questions, I'm happy to answer. It's pretty, for the sake of time, it's pretty best to just email, and I'm happy to respond.